Hi, good afternoon, everyone. My name is Levent Kürdemir, UTA Planetarium Director, and here is the next episode of Ask Astronomer. So every week we are here with you to answer your questions. You can join our live stream via chat and participate in the conversations, give your comments, and even ask questions. And of course, you can just let your friends know about this live stream if they have any questions.
Yeah, we have an awesome episode this week. I'm really excited about this event. We have something special, which I think we hinted at before, and then we got to announce officially 2 weeks ago. And last week we had a hiccup, so thank you for everybody who stuck around for that. Very grateful. Anyway, and then we have some other news also, right? We have a minor announcement, which we'll get to a little later on, probably near the end of the show. I do want to cut in to you, Levent, though, and say that the campus that we're on, UTA, does monthly siren tests, and they're doing it today. So if you guys happen to hear a siren in the background, don't be surprised.
Yeah, there is no tornado approaching to the building. And here, Jim Bader, program coordinator
Yeah.
of UTA Planetarium. Sorry, I forgot to introduce you, Jim.
How dare you?
Sometimes I can be, yes.
Anyway.
All right, so are we starting with our first news?
Yeah, I think so.
In the past, time to time, people also asked about the formation theories of the solar system, formation theories of the planets, and one of the profound questions is, how the Earth was formed, how did the sun got into the place in the first place, and how do stars form? So as technique gets better and better with the better observatories and especially advanced technology, we are starting to just bring visual evidence to our research. And one of our research, well, this has been researched heavily at the UTA campus, and one of our PhD candidates is actually working at the National Radio Astronomy Observatory, known as NRAO, and using these giant radio telescopes. And there was a recent article came up with featuring a great picture from a forming star, forming planet, and even possibly forming moon. Those are called protoplanets and protomoons or exoMOONS. Well, proto means that it is just pre or just the forming, developing. And here, Marialis Rosario, the PhD candidate at UTA, with us today to talk about this recent news and article and also the picture. Hi, Marialis.
Here. Hello, everybody. Yes.
Great
Awesome.
to see you again. We are not seeing you at the campus for a while because you are at your the research lab, right? At the NRAO.
Right. Well, we are working from home since COVID, but yes, I am currently in Socorro, New Mexico, which is where the operations center for VLA is located. Yeah.
That's great. So let's take a look at this picture. And Marialis, can you tell us what this picture is telling us?
Right. So I think before going into the specifics of the picture, a bit of a background is necessary. I must mention that what we are observing here is a system called PDS-70. And so what we have in the left panel in the center is the star PDS-70. And I have to mention that this star is still developing and forming. So us astronomers, we classify stars according to both their spectral type and where they are in something we call the HR diagram, which lets us know about the evolution of the star. So in the HR diagram, when a star becomes a main sequence star, it means it's burning hydrogen. What we are seeing is a star that it's not burning hydrogen yet. this star is still forming, still developing, very early stages of its life. And this is really important because that means that everything around it, it's also still forming and developing. And so what we see around the star is a circumstellar disk, right? It's this disk that is in the outer zone. And then in the second panel, we have a zoom in towards a planet that is called PDS-70C. And that planet seems to have a little bit of a circumplanetary disk. And this is what we are seeing in this image. And it's the first time we are able to detect a circumplanetary disk.
All right. So, Marialis, I have to cut in because this is something that drives me just crazy. Can you comment on why do we get such wonderfully catchy names from these types of objects? I mean, PDS 70.
Because it is cool, Jim. I mean, who wants to call it? Who wants to call it like George, which was Uranus at one time?
I mean,
right?
what about something more fun like I don't know, Voyager? Oh, that's whatever. You could come up with something. PDS
Well,
70.
that's actually a great question. I don't know that I'm able to answer that. I do know that with other planets, these names have to do usually with either the instrument that was used to observe them initially. So PDS might be related to that, but I'm not actually sure with PDS. But yeah, what's really awesome about this is we are seeing a whole system form and develop. And so I did send you, Jim, a picture
Yes.
earlier. In 2018, this system was also observed. And this was the first time that a circumstellar disk was observed. And so
2018 was the first time a circumstellar disk was observed.
around that
Yes.
time,
I mean,
yes. And from
the
there,
first
many others.
to be able to observe circumstellar disks, the infrared telescopes were needed. So
Right.
the infrared is something that you cannot easily observe from the surface of Earth because the Earth's air absorbs most of the infrared light. So you
That's
either
correct.
need telescopes in space, and the recent Spitzer done a great job of observing circumstellar disks, or you have to locate your observatory on a very high mountain in order to get some infrared light. But this is still not enough to observe the circumstellar disks. Mostly satellite observations are required to see, because this star is, as Marialis said, they are forming. They haven't producing enough energy yet. So because they are not producing enough energy, they are not going to look like bright stars. Their light is very low, and in the low light environment, the best thing to use is infrared light, even on Earth, right? If you have infrared camera, you can see in at dark. This is what firemen use to find like the living bodies, because like the smoky environment, so the human body glows a little bit, not as much as we can see at night, but the infrared cameras can see a glowing human body. So this is what astronomers are doing to see these circumstellar disks.
Is this what kind of telescopes and light are we using to observe this particular picture, Marialis?
Absolutely. I have to agree with Levent. So for both of these observations, both in 2018 and the recent discovery that we're about to discuss, were observed with the Atacama Large Millimeter and Submillimeter Array. So the ALMA telescope. And millimeter and submillimeter is just a fancy word to refer to an area in wavelength where both radio and infrared overlap. So with this telescope, we are able to look at both wavelengths, which gives us much more information than just looking at one. And so array means it's just a bunch of antennas all connected together. So ALMA is located in the Atacama Desert in Chile, and it is composed of 66 antennas, and it is at 5,000 meters of elevation. And this
Wow.
allows us to observe light without much light pollution from surrounding cities, without much refraction, because it's in a desert, so there is very little humidity, and so there's less light refraction from humidity. And it's also an international partnership. It's a big investment from several different countries and foundations. You have the European Southern Observatory, which is the ESO. You have NSF. You have NREO, which I work with. You have organizations from Canada, Japan, Chile itself, Taiwan. They all ship in. They all are directly involved with this telescope, and they've achieved several important discoveries, studies in comets, in planetary formation. They are the first to see planetary formation occur. They are part of the Event Horizon Telescope in association with other telescopes around the world. So they also observe black holes.
That's who took the photo of the black hole, right?
Yeah.
Oh, fantastic.
And they also were involved with the detection of phosphine in Venus' atmosphere. So ALMA is one of the greatest instruments that astronomers have at their disposal at the moment. Absolutely.
Is there any search for extraterrestrial galactic life for at the facility?
Levent goes straight to the aliens.
With other words, is the SETI Institute is getting any time from your telescopes?
So I think what we're about to discuss today is some of the closest we can get to trying to look at extraterrestrial life. And by this, I mean, there is most definitely a field out there called astrobiology. And so it uses observations of this type along with spectrographs, which actually the picture that I sent Jim shows an overlap of different observations. So you do have the ALMA observation, which is kind of what we can see in on the left, and it's on yellow. And then overlapped, you have observations from the Very Large Telescope, the VLT, and that is a telescope from ESO. And with different instruments that are attached to this telescope, you have SPHERE. SPHERE is a coronagraph. It allows us to look at the corona of the star in much detail. All that information is seen in red. And then we have MUSE, which is the spectrograph. The spectrograph allows us to decompose light and look at the chemical composition of light, which allows us to determine what is the chemical composition of the objects we're looking at in space.
Holy moly.
So as imagined, the astronomers are not just standing by a giant optical telescope and keeping one eye on the telescope to see things or do research. So there are actually a lot of instruments are connected to the telescopes, and the light or radio signal, whatever signal is gathered from space, is directed to the sensitive instruments, right? And the computers analyze data.
Absolutely. And with spectrographs like this, we are able to identify biomarkers such as phosphine in the atmosphere of Venus. And with also spectrographs like this, we are able to identify that this star, PDS-70, is not a fully formed star. Why? Because while they're not necessarily ejecting a bunch of energy from burning hydrogen, they have massive electromagnetic fields, and they produce bunch of lithium. So lithium is something that we can observe using spectrographs, or abundance of lithium. When we characterize stars using a spectrograph, we can identify the chemical composition. Looking at the abundance of lithium, we can determine, hey, this isn't burning hydrogen, this is still developing. And
that is so cool.
Definitely looking at the circumstellar disk around it, we can tell this star is still forming. And so in the formation process, the stars start accreting material from this disk with angular momentum. They start, spinning and spinning and accreting. And when they start forming, you have these little pebbles around it that start accreting as well. And they carve holes or rings in this disk. And that's how planets form. Now, it is theorized that at a smaller scale, this is also how moons form. Okay, so take a circumstellar disk and make it smaller around a planet. Once the planet stops forming, there is still material around the planet. And as these pebbles around that planet start accreting as well, that's how certain moons form. I must say that this isn't the only formation mechanism. This depends on the host planet. So, for terrestrial planets like our own, the most likely scenario of formation is giant impact. However, for giant gaseous planets, the most likely scenario is accreting from a circumplanetary disk. Therefore, this is essentially the first observation that proves or that leads on that this is a possible mechanism beyond just theories and simulations. So that's why this is such an important discovery. I must say that this observation was led by Miriam Beninsti from the University of France and also the University of Chile. And what's really great about this, it's not just that it's the first image of a circumplanetary disk, but also that they were able to determine the size of this disk. And the size indicates that 3 moons that are similar to our moon in size, 3 moons could form in that disk.
So I think you can kind of see 3 little clumps here. Sorry, I'm kind of hiding, but I think you can kind of see 3 little clumps. Is that kind of what we're looking at? Those 3 clumps, or is that too much to make that assumption from just this image?
As a scientist myself, I would say that I'd rather stay a little more conservative on that assumption.
Good. I like that. I appreciate it.
But as a fan, yes, I see them.
And that is precisely why I asked.
That's the beautiful thing about astronomy, science, and particularly astronomy. We have theories, right? People always ask, how did the moon got there around Earth? And we say, well, we don't know for sure, but we have theories. But those theories should be based on some, of course, like the first, it comes with a hypothesis, and which means actually educated guess, and then turns into some theories with some evidence. But the space, the universe, is a great experiment lab for astronomers, because we are actually proving or disproving our theories, right or wrong, with these type of research. And let's see how this research will reveal the formation of planets and formation of moons. But you also said something interesting. The star is making lithium, right?
Yes.
The
yes,
lithium,
absolutely.
and as like the most of the elements actually, they are made in stars. The people do not make those elements in the laboratories. Those are made in the stars and migrated into the circumstellar or the planetary disks, and then they are contributing to the formation of planets. And then like we have a lot of elements, including lithium, gold, and many things. Iron, for example. The Earth doesn't have any mechanism to make those, but when we dig Earth, we found those elements. Where did they come from? they came from stars, particularly from the sun. When the sun was forming, the scenario was the same. So formed and then moved outward of the solar system,
So interesting.
got into the nebulae like these, and then finally they are in the planets.
Okay, so I have to ask you, Marialis. We're looking at the image right now, and I'm curious: is this enough evidence for someone to say that we are definitely seeing a moon form, or is this just more stacking of likeliness? Could it be anything
So,
else?
well, okay. So clearly, okay. So we have enough resolution to say this is a circumplanetary disk. We don't have enough information to say this is a moon forming. However, through the laws of physics, it is only logical that this circumplanetary disk might lead to formation of objects around this planet, which are likely to be satellites. So what I would say is that we can safely say this is a circumplanetary disk, and we can also safely say that it is the first step for satellite formation according to formation theories.
That is so cool. So cool.
I completely understand your hesitation when you say circumplanetary disk, because I also used the term the circumstellar disk. So my mouth is almost going into this to say circumstellar disk each time. So it's hard because it's a new term, right?
All right, so I have to interrupt. We've talked serious stuff, and I have some. It's not really funny. It's just super interesting to me. So we have two pictures here. I'm going to move out of the way so the viewers can see them. On the right, we have a beautiful picture of a nebula that many of you may recognize as Messier object number 57. We give it a more fun name. We call it the Ring Nebula. It's located in the constellation of Lyra. Something you could see, by the way, if you went outside tonight with probably a fancy telescope if you live in DFW. This is what we call a planetary nebula. On the left is the image we've been looking at. This is so funny to me. It's funny because when astronomers first saw planetary nebulas like M57 on the right, people were, hey, like this looks like what we would imagine a star forming a solar system would look like. So they called it a planetary nebula. They had no idea what they were looking at the time was not at all that or even close. But it's so funny to me when we see a picture of actually a solar system. Oh, actually, I can't. Maybe I'm saying that a little too broadly.
Yeah,
but
the one on the left is the real planetary nebula. the the one on the right is a conceptually wrong planetary nebula.
It's really interesting to me. I don't know. At least I'm probably confusing all the viewers by saying all this stuff because we're throwing terms a little bit too loosely here. But as an astronomer myself, somebody who loves to look at these types of objects, I saw this image and immediately thought of Messier 57.
So Marialis, what is next in your goals to explore or find maybe like in terms of findings of this research?
You mean my research or the research developed here?
Your research, your particularly, what
Okay.
are you trying to achieve next?
Right. So, so my research has to do with moons, and I work with two aspects of that. I simulate and I perform simulations on computers, their orbits, and essentially I perform dynamical simulations to see if these if certain moons can hold stable orbits. And a second aspect of that is trying to detect these moons using radio waves. Similar but not like what we're discussing, I intend to try and see if moons outside our solar system would emit a very specific kind of radio wave that we see between Jupiter and Io. And so what's really cool about being able to do that, if I am ever able to make a detection, is that I would be able, yeah, I know.
We
It's that
believe in you.
I would be able to essentially probe the electromagnetic field of that circumplanetary environment. And it would give us a lot of insight into habitability, composition, etc. And these things have to do with each other because depending on the orbit of the moon, or where the moon is in its orbit, that's how the radio wave will be emitted. So certain parameters of this emission depends on the orbital phase of the moon. And so these are very cool electromagnetic interactions that we can just probe and measure with radio telescopes.
Oh, that is excellent.
I also would like to see if our viewers have any questions for Marialis or questions in general.
Definitely. We had a bunch of comments here. Brexton, hello, how you doing? Patricia, always here. Thank you guys so much. Lamia, so glad to see you back. And also hello to you, Kurt. We kind of just jumped over everybody. Hi to you also, Janet, because we wanted to get to this interview and we wanted to talk to Marialis. But let's go to the questions that we have here. Looks like Brexton says, I own some gold, so do I own particles of a sun?
Yes, actually, I would like to point out that every element in the periodic table comes from naturally. We've never seen anything else in nature that produces elements but supernovas. So you do not only own pieces of the sun or stars, you are pieces of the sun or
Coming in
stars.
hot with those references are just they give you
Like-
shivers all over. I love those.
Carl Sagan said, "We are star stuff."
Yeah, we're made of stardust. Absolutely.
We have another question that also asks, Marialis, have you seen a UFO in your studies? This is what happens when you live stream. Should we go to a break right now? I'm just kidding.
To be honest, during observations, I've never seen anything that didn't have a logical explanation. Not that I haven't seen weird stuff, but then when you look more into it, it's like, oh, that's a cosmic ray, or oh, that was just a car that turned on their lights and it's interfering with my, you know, or oh, the camera was dirty and it disappears after you clean the camera. So honestly, not during observations. Maybe living in Socorro, I might have seen
Oh
things
no,
with the
she's
naked
just throwing
eye,
fuel on the fire.
with the naked eye that I'm not familiar what they are, but it's not something that doesn't have like three possible logical explanations before I jump to, oh, those are aliens. I'm hopeful that they'll find me and take me, but but to be honest, not really. Sorry to disappoint.
All right, I do want to reiterate, if anybody has any questions for Marialis or about the subject matter that we had at hand, please feel free to drop questions in the chat. We had some other comments. Thank you guys for those so much. And do you want to respond to Kenneth Levent?
What is the question?
It's kind of not exactly a question.
Okay, some sun exploded 1 billion years ago, and now I have to pay taxes. No, they are tax-free events, so they are not. Nobody is taxing us for the events happening in the celestial environment.
Well, I mean, the way this stuff, the way I guess the cookie crumbled, yeah, he has to pay taxes because the sun exploded somewhere 1 billion years, 5 billion, 6 billion years ago. We have a question from Kritzia, who says, where did you search for exoMOONS?
Okay, that's a great question.
Like where in the sky? She goes on.
Right. So currently I am using the LWA It's the long wavelength array. It's also located here in New Mexico. Unlike the VLA, it's not an array of big antennas, but instead is an array of small antennas. And so we're in the sky. Currently I'm looking at a binary system. It's called Groombridge 34. And I'm looking there because it's close enough that the intensity of a possible signal will be detectable. And it has the necessary parameters to have a Jupiter-like and an Io-like planet-moon system that might emit the same kind of signal. That's a great question. Thank you.
Uh,
I don't. I don't quite remember. I'm sorry. Not off the
and
top of my head.
you are saying VLA. VLA stands for very large array, right?
Right.
And also,
So that's
yeah,
that's
that's
the VLA. It has 27 antennas. And
mhm,
yes, that stands for the Very Large Array, located here in Socorro, New Mexico as well.
yeah.
Um, and and it's directed by NRAO. Yes.
And the astronomers are using these telescopes in arrays because they actually combine signal to get, let's say, better reception, better transmission, better signal quality. So all the telescopes are used in arrays. So that's a huge investment. It's expensive.
Absolutely. However, it's much more efficient than attempting to create a single dish telescope with that much resolution. So, astronomers, yes, we have Arecibo. That's a telescope from my homeland. Yes, that's my homeland's telescope. It was the telescope with the biggest single dish for 50 years. It made incredible detections and advances in science. And what's cool about Arecibo is that it was also an emitter. So it wouldn't just receive signals, it would emit and receive whatever bounced from either the atmosphere or solar system objects. However, if you want only a receiver, it is much cheaper to achieve good resolution by creating an array of several antennas together and essentially summing all those signals together to achieve the desired resolution. I cannot say that this is the same for emission. I think Arecibo was the best instrument for emission.
Certainly.
Um, but for
Lamia has a
receiving, it
question
is
here.
much cheaper to have arrays.
Lamia has a great question. Are there more than one theory for formation of moons and planets? If so, seeing an evidence for a certain theory would lower other theories' possibilities or not?
That's a great question. I love that. Okay, there are 3 different theories that are favored by scientists. So for our own moon, the giant impact theory is the one that fits more the current parameters of our Earth and our moon because the size ratio, and by that I mean the difference in sizes between our Earth and the moon, is not big enough. You can think of our planet moon system as kind of a binary of 2 objects that are similar in size orbiting each other. This is not true, though, for giant planets. Giant planets have larger differences in sizes. And the formation theory that favors moons around giant planets is the disk accretion formation. And there's another type of satellites that we call irregular satellites, and that's where the third theory comes in. Irregular satellites are satellites that have high eccentricity, and by that I mean that their orbits are not quite circular, more elliptical, correct, more elliptical. And for these, there is the capture theory. And actually, we've seen that Earth has captured small satellites for a small amount of time, and then these satellites either go away or crash into our atmosphere and decompose into tiny meteorites. So capture is another mechanism that is widely accepted for satellites that don't seem to have the right masses or seem to have very elliptical orbits. So these three formation theories are accepted because they fit and explain the resulting parameters of these satellites. I would not necessarily cancel the other two theories, and by that I mean capture and giant impact, because they explain other types of scenarios. So giant impact is a good explanation for terrestrial planets and binary-like planet-moon systems, and capture is a good example for irregular satellites. And it's something that we have also observed. But because we observed irregular satellites on Earth, like for example, I think a couple of years ago, Earth captured a meteoroid, and that meteoroid orbited Earth for 3 years, and then it caught enough escape velocity to leave. And that's it. It was there for 3 years and then it left.
So there may be more moons than we know of, right?
Exactly. So because that happened, we cannot undervalue the disk formation theory, because that explained a whole other type of satellites for a whole other type of planets. So I don't think we can disqualify either of those three. I think those three are very good explanation for very different type of satellites.
Yeah, great. Kurt also has a good question. So he's asking whether the Arecibo will be repaired or not. And also, I'm curious too, you mentioned about the transmit capability of Arecibo. Why do we need to transmit? Or when do we need to transmit?
Wow. Okay, so I'll try not to get emotional.
Are we
Arecibo.
talking to aliens here? What's going on?
Okay. Arecibo is a telescope that's very close to my heart. I am originally from Puerto Rico, and I lived for 22 years. I was born and raised there. So the loss of Arecibo has had a big impact on me, and I might be biased, but here's why Arecibo is unique, or was unique. First, will it be rebuilt? I don't know that for sure. I do know that there are many groups that are pushing towards that. I'm pretty sure that NRAO is also in contact with the former directors of Arecibo, and there are many proposals going to NSF to reconstruct it. Recently, this summer, there was also a workshop teaching astronomers, astrophysicists, and whomever was interested to write proposals so that they can submit it to NSF, so that NSF can read these proposals and decide what they're going to do with Arecibo. So that's still in progress, but there are many efforts going on. And secondly, the emission capabilities of Arecibo. Okay, so first off, Arecibo had a giant dish, which provided a great amount of resolution that was extremely, extremely helpful for many discoveries. That's the first thing. Secondly, the localization of Arecibo is in Puerto Rico, my homeland, which is very close to the equator. So by that, through that location, we are able to look at solar system objects with very, very little effort and a lot of resolution. Why? Because the equator of Earth is parallel with the orbits of the solar system. And by this, we say we have a coplanar system. So all the orbits around the solar system are more or less aligned, with the exception of some stragglers, but all of them are more or less aligned. And so these orbits of solar system objects are also aligned with the equator of Earth. So because Arecibo was located so close to the equator, it was able to observe with very little effort for many amount of hours. And so what we would do, what scientists would do with Arecibo, they would emit a signal. This signal would get caught up in the atmosphere of the object that they wanted to observe. Let's say we want to observe Jupiter. So after interacting with the atmosphere or the atmospheric composition of that object, it would bounce back and be received with the giant dish and provide us with a great amount of information about the composition of these atmospheres, about, well, everything there is to know.
And also
about
potentially
those
help
solar
calibrate
systems.
the telescope as well, right?
Sorry?
It may potentially help the calibrate the telescope as well, because I'm not sure if they are used in the radio dishes, but in the optical telescopes, for example, the Hobby Eberly telescope at McDonald Observatory is using a laser. So they shoot the laser in the air and it bounces back, and they analyze the laser, the computers analyze the laser beam returning back and gets the good idea of how the atmosphere is affecting the observation, and immediately subtract that effect from the data received. So what you get is all the atmospheric effects are eliminated. So it feels like, you know, you took the image from space, not from the ground of Earth.
Absolutely. And
We're getting some.
with
Go ahead,
Arecibo,
Marielle. Sorry.
I'm so sorry. But similarly with Arecibo was used to perform ionospheric studies in our own atmosphere. And so they would also do the same. It's subtract the ionospheric effects from particularly low frequency emissions, low frequency studies, which are very affected by ionospheric effects. Submit that to the ionosphere, subtract it, and have a clear observation. Go ahead, Jim.
Sorry. Yes. Yeah. So we're getting lots of comments. Seems like a lot of people are sending their condolences about Arecibo. I know that I can echo what Kurt said. He said, I am heartbroken over Arecibo as well. I'm just considering costs. I'd love to see it rebuilt. I 100% agree. Kritzia says, this is more about Puerto Ricans' access to astroscience. It's invaluable. And I can't imagine that not being true. And then we have one other comment from Kenneth that says, is Arecibo the coolest looking observation system? I want your take on this, Marialis, if that's possible.
Well, I think it depends on what you want to look at. Arecibo is great for, actually, Arecibo was first line in, what was it called in English? Planetary security. Essentially, Arecibo was the best telescope to check if asteroids were incoming or might crash with Earth. So
Yeah.
Arecibo was one of the first instruments that NASA used for planetary defense. Yeah,
I did know that. I was aware. That's super cool. But it's the way it looks. Arecibo looks so cool. I mean, if I show it to everybody, I mean this is, I don't know if you would say that this is in its prime, but man, that's cool looking. And how many other giant telescopes did you get to see blow up in a blockbuster movie? I mean, come on.
Absolutely. You know, I must point out there are other single dishes telescopes out there. There's FAST in China. It's achieving great resolution as well.
Yeah, VLAs are also
and
pretty cool looking too, especially the giant dishes on the train tracks. They are moving them around. That's amazing. Amazing construction.
Here's FAST in case the viewers are wondering what she's talking about. This is absolutely enormous in China.
The difference is you don't FAST does not have the hanging structure, and that hanging structure that Arecibo has is where the emitter is located. So
we can
PASS does not emit, it only receives.
we can talk for hours and hours, Marialis, but we have
Absolutely.
to end this stream sometime. But it's certainly great talking to you. Is there any more comments or questions, Jim?
Yes, but I do. I want to bring. We had one other. Actually, we had a lot of stuff we thought we might talk about today, and it's okay. I'd much rather be having this conversation. But we had a launch just recently, and I want to know everybody's reaction on it. But also, I think because we have Marialis here, it would be a fun to do that. Marialis, I don't know how much experience you have or knowledge you have or how much you keep up with space launches and so on and so forth, but I'm really curious about how you feel about this. So I want to show this. Thank you, everybody, for your questions with Marialis. If you have additional questions, you can drop them in the comments. I will send them to her, so she definitely gets those, and we can try to get answers back to you if possible. But without further ado, I want to show this image because it is kind of crazy, Levent. You might scoot over to your left just a little bit. This is the recent Astra launch that happened on this just past Saturday. Levent, does this look like a normal launch to you?
No, this looks to me some things are awfully going wrong in the wrong direction. The right direction is this.
Yeah. Okay, I need to say before I laugh too much about this, space is hard. These people are working incredibly hard. They're spending tons of time and effort and money to make this work, and stuff goes wrong when you do space, right? Space stuff goes wrong. So, right before we leave, Marialis, how does seeing something like that make you feel as somebody who does research, not necessarily in rocket technology, but you understand what's happening there? How does that make you feel?
So I am by no means an engineer. Well, my first question is, why is it traveling horizontally?
That's what we expect from a rocket, right?
The horizontal travel, just to tell you, most people think they haven't released an actual statement yet, but as far as I can tell and do research in my assumptions, that rocket has 5 engines set up in a pattern similar to what the Saturn V rocket has. So one of them being out would probably cause it to shift. It didn't. I mean, obviously it was a failure. The rocket did launch. It did get something, I don't know, really, really high in the air. I'm not going to give numbers. I don't have it written down off the top of my head. But either way, yeah. Sorry, go ahead. This horizontal was not a good thing.
And I guess another thing is, this is kind of how we develop, no? So trial and error, and I'm guessing that what follows is a troubleshooting process, identify what went wrong, try to fix it, try it again. And this is how we achieve progress. And this is very much how research goes, at least for me. Like sometimes you're spending days trying to figure something out, you realize it's wrong, you have to
everything goes wrong. It has to be so devastating. The good news is it was a test. There was just a mass satellite. It was just there was a mock-up satellite inside, so nothing was actually lost other than, I'm sure there were some very sad folks at Astra and for the Space Force, which is who they're working for.
Right.
Any last comments, Levent?
No, well, Marialis and Jim, thank you very much.
Thank you.
It was a great stream, and hope to have you on another stream, hopefully, Marialis. And again, for our viewers, if you have any questions or comments or any topic that you would like us to bring up next week, put it in the comments. And for today, see you next week.
Wait, I have one more thing we got to bring up. This is important. Kurt just commented, and this is a great segue for an excuse. Kurt said we need to start having 2-hour shows. We went way over with Marialis. This was just it was on fire. I couldn't stop. I was not going to let this end. Levent, you and I recently had a discussion about doing a second live stream, right?
Yes, rather than actually Brexton's first recommendation for 1-hour show, and I can see as we extend now the demand for 2-hour show. Well, I'm afraid it's going to be too long, but we just thought about rather than a 1 stream, maybe we can do a 2 stream. and one stream would be on a different platform that we will announce later. So you can follow us on both platforms, and we are just hoping to reach more people with 2 streams in a week.
Definitely. So I want to ask all the viewers, everybody, please, if you have recommendations on what we should do, what kind of format you're looking at, put it in the comments. We want to know. And I mean, this is programs that we do to interact with the public, with you guys that pay attention to us, but also Levent and I both, and you can attest this, we love talking about space stuff. So giving us another outlet is...
I mean, we don't want to do both streams alike. Certainly, we don't want to repeat ourselves, but we need help about formatting. Like we can, during our regular streams, we can talk about space news. We can talk about what's going on in the night sky. We can talk about, you know, the research, recent discoveries, and so on. Or just we may have the open conversation with the viewers. You ask and we answer.
Let us know. All right, Levent, that's it.
All right. See you next week
Yeah, see you
on
everybody next
Facebook.
week.